Hello everyone, welcome to my channel. So now we are going to do Leetcode weekly challenge. Second question, count the number of houses at a certain distance. Okay, so let us first read this question, then about constraint, and then some examples, and then finally the coding part for the same. So you are given three positive integers n, x, y. In a city, there exist houses numbered 1 to n connected by n streets. There is a street connecting the house numbered I with the house numbered I plus 1 for all 1 basically I which is greater than or equal to 1 and less than equals to n minus 1. An additional street connects the house x with the house numbered y. Basically all the houses are interconnected with each other, but there is, out of all those houses, there are two houses which are interconnected with each other with one additional street. So for each k here refers to distance such that k is greater than equals to 1 and less than equals to n. You need to find the number of pair of houses, house 1 and house 2, such that minimum number of streets that need to be traveled to reach house 2 from house 1 is k. And we are required to return one index array results of length n, where result of k represent the total number of pairs of houses such that minimum streets required to reach one house from other is k. And note that x and y can be equal as well, means same house. Now here, if we see this first example, let us first see constraints. So constraint here are pretty much low that n square solution could easily work as well. So that is what is meant by this much constraints. So now let us first check this first example which is given. Now here n represent number of houses which are 3, right? We can see that there are 3 houses. Then x equals to 1 is this one and y equals to 3 is this one. It simply represents that there is one street which is connecting these two houses. That is what it was mentioned there. Now we are required to return, means we are required to return one indexed array as an answer, where we will be having count of all those pairs which have that much distance required to reach that pair. Means here distance 1, distance 2 and distance 3. And here number of pairs which are there, mean number of pair of those houses which are there. So that we are required, means count of those we are required to be written here, whose distance between them is 1, 2 or 3. So now here we can see this one, here the distance is 1, here also distance is 1, here also distance is 1, and we can also go in both directions, right? So in that context, we have 1 to 2, 2 to 1 means into 2, right? Then 2 to 3 and 3 to 2 into 2, 1 to 3 and 3 to 1 basically into 2, right? So that's why here we have 6 pairs. Now for distance 2, as we are required with the minimum one, right? So for distance 2, we won't be considering any. So that's why here 0. And for 3 also 0. So that is why they have returned this particular answer. So this is what they are asking in this particular question, and that is how they are required to get the answer. Now comes the part. Let us take for the second second example which is given to us. Now here in this second example, we have 5 houses. So now in this 5 houses from x equals to 2 to 4. Now here if we check, um, क्या हो गया इसको? 1 minute. Okay. Now here if we check for all the 1 distances, 1 to 2, 2 to 1. Then so here we can clearly see that this 4 into 2 and this one 2 to 4 and this one, right? So here we can see 5 into 2, that this 10 pairs are there, right, for one distance. So that's why here 10 they are having. So now comes the part for all the two distances. So here if we see 1 to 2 is 1, but if we want to go for 3, so it will be this one, right? Then same goes with if it wants to come back, right? So then also, so it becomes 2 into 2, basically 2 times 1 is there. And if we want to go from 3 to 4, basically we want to go for 3 to 5, right? So we need to cross this one, and same goes here and there. So now 2 are there for 2, and now if one want to go till 3, that is done. If 2 want to go till 5, then it need to go by this, right? So now it has become one more times 2, right? So these are 3 pairs. Now comes the part if if one more is missing. 1 to 3, right? If we want to go from 1 to 4, right? 1 2 and then this one 4. Then same here and there. So another, right? So 2 into 4, that would be 8. So this is the one. Now if for the three distances, so for that purpose there is 1 2 5, right? So this become three distance. And now if it want to go from, this was for 1 to 5, and now the same going backwards, so it will become 2, right? So that is how it become 2. And for the 4 and 5 all are 0, so that's why we are having this as the answer. So like this, basically we are required to return the minimum possible distances for each pair. That is the thing. Now comes the part that how we can calculate the minimum possible distance for this. So for that purpose, what we can do is we will be checking if from a particular I to j, the distance which is there, is it that the minimum distance, or if we take some other path and go to that j, is that the minimum distance? So out of that, whatever minimum would be there, so that we will be storing in our result. So this is how we are required to go ahead and code this particular. Now let us go ahead for the coding part for the same. So here's the code for the same. Although this is not my solution, this I have taken from that discuss, because it was much optimized, so I've taken it as it is. I've not modified anything into the same. But whatever it was mentioned, that all I have explained, and that is what it is here. So now first thing is that here the person wants that x should be greater, means this x should be always less than equals to y, means because there could be any example which could be given as like where x is equals to 4 and y is equals to 2, although they mean that the path is between them and it is already bidirectional. So it already implies same, but for our calculation purpose we are taking that x should be always less than or equals to y. So that is the case. Now here that's why if there is a case where x is greater than y, then we will be returning, means we will be calling again this function and swapping the values of x and y. Now again we will be proceeding ahead. Here we are taking a result vector, basically this particular, which we are required to return at the end. At the starting we are initializing with 0. Then we are running a n square loop where where our I is from 1 to n, and where our j is from 1 to I, so that we get the distance between I and j, whatever distance is there. Now here first thing is that we are checking the distance between I and j, right? And then we are required to calculate the minimum of this distance which is there. And if we take any other path, means any other means x and y values which are given to us, if we take that value as well, means subtracting from j and subtracting y from I and adding up 1, because in subtraction we are somehow subtracting, uh, there is one number which is subtracted twice, so that's why we are adding up that one number again. So that's why we are checking that if this value which is coming up, or the one value that is I minus j, if that out of both of these, which is the minimum value that we will be storing in this particular index. And now here, because what we are doing is, although we are required to return the one indexed result, but the resultant itself is basically zero index, means the vector starts from zero indexing, right? So that's why whatever is being stored at, means whatever idx equals to 1 would be there, it is required to be stored at b of 0, right? So that's why we are storing it like this. So that this is the main context for the same. And why we are adding up 2 to the same? Because it is bidirectional. From 1 to 2 we can go, and 2 to 1 we can go, so that's why we are adding 2 at that particular point. So this is the thing. And here we are basically checking that which is minimum distance out of both, so that at that particular index we can store that 2 value which is there. Means see here, going from 1 to 2, and then from 2 to 4 we get 2 as the distance, right? But if we take 1 to 2, 2 to 3, 3 to 4, here we get distance as 3. So we will be checking that if this particular is minimum or this particular is minimum, but this is not minimum, this is the one. So that's why at this particular index in the resultant, by subtracting it with 1 so that it becomes 0 indexing, but the value which we are getting, that is as per the 1 indexing, right? So that is what we are storing here and adding up to, because it is a bidirectional distance, right? So this is what we are required to do, and at the end we are returning this resultant. Now comes the part for the time complexity and space complexity. So we are not using any extra space, but the time complexity here you can clearly see that it is n square, because here at max this means j equals to 1, right? And at max I can go up to n, right? So that's why in that context this will also be n and this will also be n, so n square. So that's why time complexity becomes order of n square, and this is as per the constraint which are mentioned permissible, right? And the space complexity is order of 1, because we are not using any extra space. So this was all for this particular question. If you have any doubt, you could comment that down. And if you really like the explanation, you can like, subscribe, and share this video among your friends. So this was all. Thank you.